In the last video, we introduced limits and discussed how to compute them algebraically, graphically, and using a table. In this section, in Module 2b, we're going to look at what we call local linearity, and then also from that, talk about rates of change. Okay, and we have these different learning objectives that we hope to accomplish by the end of the module. So let's first dive in and talk about local linearity. So in Module 2a, we kind of talked about how limits are really just a function or a y value that we that the function approaches as we increase or decrease the independent variable x typically to a specified value, or if we let x grow without bound positively or negatively to plus or minus infinity. But with the idea of limits, we can also view it in a different way. We can say, well, now limits, we can actually think of the limiting process as analyzing the behavior of a function in a small region. And to do this, we really want to think about how does a continuous function, and again, continuous function is a function whose graph, if you want to think about the graph of it, can be drawn without stopping your pencil or lifting it up and starting again. So it should be a smooth curve that you can draw in one smooth motion. And then we also want to add the condition if we don't have any sharp points. How does a function like this behave in a small region? And so I'm going to open up a program called GeoGebra, and here I have the graph of a function x squared times sine x all over x plus 2. Okay, so I have this function here, and its graph is here, and so the idea of that we want to explore is what happens as we zoom in continually on a part of the function. Okay, so I'm going to look at this little hump right in here. It's around, say, x is 3. And we want to analyze what happens to this little hump as we zoom in. And specifically, I'm going to look right around that little peak. So I'm going to go ahead and zoom in here. Okay, so the hump looks to be around about 2. I need to readjust my window here. I'm going to keep zooming in. Okay, and so we're getting closer, and you can see, if I get rid of this window here, I can actually select the curve and put a point on the point of interest. So let's say I'm going to look at point A here. And so I can continually zoom in and see what the behavior around point A is. So zooming in, okay, it's getting a little flatter. It now looks like a parabola, sort of. And so we have this behavior. Keep zooming in, and if I zoom in some more, I need to readjust my window. Okay, we can see if we zoom in far enough, this is actually, it looks like a line. Okay, so if I zoom in far enough, I can actually approximate in the neighborhood around A with a line. Okay, and so going back to our lesson now, if that happens, if I can zoom in and get a region in a small region around a point of interest to be a line, we call that that the function is locally linear, or we can say that it has the property of local linearity. Now this is really nice because in Module 1 we started studying lines and rates of change, and started modeling different scenarios with lines. And so the reason this is so powerful is because we have different properties of average rate of change. We know about how to interpret the slope of a line, and we can do a lot of nice mathematics with lines. Okay, so that's a brief overview of the idea of local linearity. So zooming in on a function at a point and looking in a region, small region again, really close around that point, or really in a neighborhood around that point, and if it is a line, then we say it's locally linear. Okay. In the next video, we're going to discuss the different properties that local linearity brings, specifically the relationship between average rate of change and what we're going to come to call instantaneous rate of change.